The greatest common factor is the biggest number. I'm going to give you the definition in a second. It's the biggest number that goes into a set of numbers or divides into. Okay, so it's related to division. In fact, if you can read, you might be able to see the definition there on the left side of the screen. The greatest common factor is the biggest number, okay, or largest, that can be divided evenly into a set of numbers. Now, why a set of numbers? Because normally you're only interested in two, but you could use 3, 4, 5, 6. It's the biggest number that divides evenly into those. We're going to be using prime factorization, the lesson we did yesterday, to solve the problems that we're looking at today. Okay, so we're finding the greatest common factor of 20 and 12. First step is to find the prime factorization of both numbers. 20 breaks down to 5 and 4, which goes to 5, 2, 2. And then 12 breaks down to 4 times 3, which breaks down to 2 times 2 times 3. So step 1 is just like what we did yesterday. Step 2, we're going to circle the factors they have in common. What do they have in common? The left and right. Which factors they have in common? Somebody raise their hand. Gage. We're talking about the prime factorization. They both have what? And how many of them?
4, 2, or they have 2 on each side.
Yes, thank you.
But they have 4.
Okay, they have 2 in common, right? They have 2 factors in common and they're both 2. Does everybody understand that? I'm not circling the 3 and 5 because that's not common factors. So that's step 2, circle common factors. Step 3, all we have to do now is multiply those factors to get the GCF. So what's 2 times 2? 2 times 2 is 6? 4. That gives you the greatest common factor. In other words, 4 is the biggest number that divides into both 12 and 20. Yes. Now, why this works, I didn't really explain why this works, but if you think about it, if they both just have 2 and 2 in common, that means 2 and 2 divide into both of them, right? So if we multiply that, that means 4 divides into both of them. But the reason why we can't do the 3 and the 5 is because those are different factors. So if I try to divide, say, 12 into 20, it won't work because 20 doesn't have a 3 as a factor. If I try to divide 20 into 12, that's obviously not going to work. You can't divide a bigger number into a smaller one. And so we can only circle the common factors to find the GCF. Let's try 36 and 108. What's the prime factorization of 36? It's going to be 6 times 6, which breaks down to 3 times 2 times 3 times 2. If I do the prime factorization of 108, any ideas on that one? 11 times 9, that'd be 99. 12 times 9. Oh, I think you're right.
Yeah, I think it's 36. 36 times.
Good call. He kind of saw a shortcut. If 36 goes into 108, then that must be the GCF because nothing's bigger than 36.
The way I did that is
Here's the other way to do it, okay? 12 breaks down to 4 times 3. That breaks down to 3 times 3. And then breaking it down one more would be 2 times 2 times 3 times 2, times 3 times 3. So on the right we have 2 2s and 3 3s, and on the left we have 2 2s and 2 3s. So actually the common factors, circle a 3 here and a 3 here, circle a 2 here and a 2 here, circle a 3 here and a 3 here, circle a 2 here and a 2 here. So they have 4 pairs of common factors.
oh, so it has to have if you're just circling a 2 on the left, it has to have a 2 on the right.
That's right. Okay, and so that's step 2. Going down to step 3, we're just going to multiply those 2's and 3's together. So the GCF is equal to 2 times 2 times 3 times 3, which equals what? 36. Yeah, I think the more examples we do, the more you're going to catch on. We're going to do a few examples with 3 numbers. But for right now, let's do 91 and 39. We broke 91 down yesterday into what? You may remember? 13, 7. Good. How about 39? 13 times 3. This one's going to end up being easy, right? What's the only 2 factors we can circle? Right, those are the only 2 factors they have in common. And so the GCF of this one is very simple. It's what? 13. Again, 13 is the biggest number that we can divide these numbers by and get a number back. 91 over 13 is 7. 39 over 13 is 3.
What if, will we ever have it where, like, say, for example, 91 or 39, one of the set of numbers we're looking for the GCF for, what if one of those are prime? Will we ever have that?
We just did. 13 is a prime. Oh, if the number we're looking at is prime?
Yeah.
Yeah, you could do the GCF of 91 and 13. It'd be 13. Yeah. So that doesn't really affect the problem too much.
Okay.
Let's do 3 numbers. So we're going to do 180, 84, and 48. In other words, the biggest number that goes into all 3 of those. So obviously the 180s we learned yesterday has a ton of factors. Let's do this one real quick. It's going to be 18 times 5, which breaks down to 6 times 3, and the 5 carries down. And the 6 times 3 breaks down to, let's do the 2 first. 2 times 3 times 3 times 5. Okay, how about the 84? What does that break down to? 21 and 4, which breaks down to 7 times 3 times 4. And how about the 48? Okay, or 6 and 8, which breaks down to 3 times 2. I'm really running out of room here. Let's see if we can do it down here. Yeah, this will be better. It'd be 3 times 2 times 2 times 4, which is 3 times 2 times 2 times 2 times 2. The 48 has 4 2's, which would be 16 times 3, which is 18. Okay, so now what we have to do for step 2 is just circle those common factors. Oh, you're right, the 4 in the middle, let's see if we can go down here, is going to become 2 2's there. Thank you, right there. All right, now we've prime factored it. So let's just start and see, yeah, they all have a 2 in common, right? Okay, so let's just make sure all of them have a 2. We're going to circle all 3 of them. And yes, they all have a 3 in common. Can we do anything else? Well, if we try the 3 for the, if we try this 3 right here, okay, the 48 has a 3, but not the 84, right? They all have to have a 3, so we can't do that one. And 5 obviously doesn't show up in the other ones, so we're done. We only have 2 and 3 that they have all in common. So the answer for the GCF equals 2 times 3, which equals 6. So 6 is the biggest number that goes in all 3 of these. You cannot find a bigger number, okay? If you tried 12, it won't work, okay? 12 does not go into 180. Has to work for all 3. Any questions on that one? Okay, let's do another one that has 3 terms in it. 66, 99, and 110. What does 66 break down to? Okay, or 11 times 6, which becomes 11 times 3 times 2. Okay, 99, 9 times 11, which becomes 3 times 3 times 11. 110 becomes 11 times 10, which becomes 11 times 5 times 2. Interesting, huh? What are we learning with this problem? Yeah, they only have one common factor, which is 11. We can't do the 3 because there's no 3 for the 110. We can't do the 2 because there's no 2 in the 99. So the reason I did this example is because it has to have it for all 3, right? You can't just pick and choose for 2 of them. So the final answer for the GCF is 11. Okay, we'll do one more and I'll give you the worksheet. I made the last one the most challenging. 147 and 210. What could possibly go into 147? Nope. How about 49 and 3? I know 3 goes into it because if you add 7 plus 4 plus 1, that's 12. And 3 goes into 12. All right, so now we can break down the 49 into 7 times 7 and then drop the 3 down. How about the 210? Bunch, right? 105 and 2. Okay. Can we get closer than that? 10 and 21? How about that? Okay, that breaks down to 7 times 3 times 5 times 2. Now, we can circle the common factors, which would be what? 7. And what else? 3. And that's it. So the GCF would be, no. If they both have a 3 and a 7 in common, what would GCF be? Not hearing anybody. Yes, 21. You multiply them. Look what step 3 says. Multiply the common factors to get the GCF. So that means that 21 is the biggest number that goes into both 147 and 210.